We are continuing along with solutions to Physics GRE GR1777 and number 21. Let W subscript P, W subscript D, and W subscript alpha be the cyclotron frequencies of protons, deuterons, and alpha particles respectively in the same magnetic field. The frequencies are related by which of the following assume that the particle masses are in the ratio 1 to 2 to 4. So deuteron is basically hydrogen with a neutron also, so that's where the 2 times the hydrogen mass comes from. And we know that T, the period, equals 2 pi r over v equals 2 pi mv over qvb equals 2 pi m over qb. So W of the cyclotron equals qb over m, and the proton mass equals m, deuteron equals 2m, alpha particle equals 4m. Alpha particle is basically the nucleus of helium, which is two protons and 2 neutrons. So we then have, if you plug in our masses to the W of cyclotron, we have W of the proton equals qb over m. We have W of deuteron equals qb over 2m, and we have W of the alpha particle equals 2qb over 4m. The 2, if you notice the charge up top, because there's 2 protons, and so the 4m from the 2 protons and 2 neutrons. So, therefore, W of P is going to be greater than W of D, and 2 over 4 is the same as 1 over 2, so W of D and W of alpha is going to be the same, and that is answer E. Number 22, the emission spectrum of the doubly ionized lithium atom Z equals 3, A equals 7 is identical to that of a hydrogen atom in which all of the wavelengths are. So doubly ionized lithium means 1 electron and 3 protons. So hence the 2 plus plus signs. So therefore the first shell, n equals 1 for both hydrogen and lithium plus plus, because of the 1 electron. So the hydrogen energy is going to be E equals negative HCRZ squared over N squared, and we have Z equals to 1 for hydrogen. Z is the proton number, and N again equals 1, so that's going to equal HCR. The lithium energy of the doubly ionized lithium is going to be E equals negative HCR times Z squared, which is 3 squared, over N squared, and remember N is equal to 1 also, so that equals 9 HCR, where E equals HC over lambda, and lambda equals HC over the energy. So since the energy spectrum of lithium, the doubly ionized lithium, is 9 times more than hydrogen, the wavelength of the emission spectrum wavelength is 1/9 that of hydrogen, and so that is answer A. Decreased by a factor of 9. Number 23, in an atom of hydrogen, the electron is bound to a proton. In an atom of positronium, the electron is bound to a positron instead of a proton. Which of the following gives the approximate Reinberg constant for positronium? And it's for a nucleus of infinite mass, R subscript infinity equals M subscript E times the quantity E to the 4th. E to the 4th being the fundamental charge, divided by 8 EO squared CH cubed. And so we have R subscript M. Here we're going to say equals R subscript infinity divided by divided by the quantity 1 plus M subscript E divided by M, where M is the mass of the nucleus. And in positronium there is no nucleus. There's just a positron and an electron. So M equals M subscript E. So the nucleus equals the mass of the electron because the positron mass is the same as the electron mass. So R subscript M is going to equal R subscript infinity divided by the quantity 1 plus M subscript E divided by M subscript E, and m subscript e divided by m subscript e is 1, so 1 plus 1 is 2, so that's going to equal r subscript infinity divided by 2, and that equals 0.5 r infinity. That is answer B. Number 24. Which of the following gives the total spin quantum number of the electrons in the ground state of neutral nitrogen, where Z equals 7? So from Hund's first rule, the highest multiplicity has the lowest energy, and the multiplicity is going to equal 2s plus 1, so the max would be s equals 1/2. So the first shell has 2, which would be 2 of the electrons, and the second shell has 5, which would be 5 of the 8 electrons that each of those shells could hold. And the subshells are filled as 1s to the 2, 2s to the 2, 3p to the 3, and those powers are not actually powers, they're the amount of electrons that are in each of those subshells. So for example, the 2p3 subshell has 3 electrons. So the 1s2 shell has one of the positive 1/2 and one of the negative 1/2 spin electron. And the same is true for the full 2s2 subshell. But the partially filled 2p3 subshell is only half full, and the electrons in it take on the highest multiplicity. So note that in the full subshells, they are going to cancel each other out and be 0, the plus 1/2 and minus 1/2. But in this 2p3 subshell, each is going to take on the available positive 1/2 spin value. And so that's going to be the total spin equals 0 plus 0. Those are the first 2 subshells that we just talked about. Plus 1/2 plus 1/2 plus 1/2, that's going to be 3/2. It's all coming from that 2p3 subshell, and so that is answer C. Number 25. Consider a Hermitian operator A hat with the property A hat to the 4th equals 1. Which of the following is an allowed pair of eigenvalues of A hat? So for Hermitian operators, the eigenvalues are real. Furthermore, the problem states that A hat to the 4th equals 1. So the only real numbers given that satisfy this, and the keynote is only real numbers, given that satisfy this are -1 and 1. And so that's just answer B. Number 26, consider the kinetic energy operator T hat and the Hamiltonian operator H hat above. And there it is above. Which of the following pairs of observables can be measured simultaneously with no restriction on their precision? So we are going to lean on the fact that we know our Heisenberg uncertainty principles, where delta P delta X is greater than or equal to h bar over 2. So this is going to be greater than or equal to, h bar over 2. And our uncertainty, our energy, times our uncertainty in time is going to be greater than or equal to h bar over 2 as well. These are our 2 uncertainty principles that we need to know for this exam. So let's just walk through the answers and rule them out as we go. So for A, this has the momentum and position uncertainty, so we have a restriction on the precision, so it's not A. So for answer B, E equals P squared over 2M and has the momentum and position uncertainty. So again, we can rule that out for answer C. H has dependency on X in V of X and therefore has the momentum and position uncertainty. So again, it's not C. For D, H has dependency on X in V of X, and T has a dependency on P, therefore has the momentum and position uncertainty, so we can rule out D. And so it must be E, but let's look at E. So T is the energy and P is the momentum, and those are not paired together in an uncertainty principle. So that is our answer. Answer E. 27. Electromagnetic radiation emitted from a nucleus is most likely to be in the form of. And gamma rays are electromagnetic radiation that arise from the radioactive decay of the nucleus. Nuclei are very small and emit photons with a short wavelength and very high energy. So if you're emitting something from a nucleus, you are going to be high energy, very small wavelength, and that is gamma rays. 28. A sample of nitrogen gas undergoes the cyclic thermodynamic process shown above. Which of the following gives the net heat transfer to the system in one complete cycle, where it goes from 1 to 2 to 3 back to 1? So the area enclosed by the system is the net work, which would be the heat transferred to the system. The area enclosed, we know the area of a triangle is going to be equal to 1/2 the base times the height. So therefore, let's look at the height here. The height is 6,000 minus 2,000 is 4,000 in a particular set of units. So the area is going to equal 1/2 the base times the height. The height is 6,000 minus 2,000 is 4,000, and the base is right here, 0.03 in a particular set of units minus 0.01 in a particular set of units, and that is going to equal 1/2 times 4,000 times 0.02, and that's going to equal 40 joules. That is answer C. 29. For an ideal gas, consider the 3 thermodynamic processes labeled 1, 2, and 3, shown in the PV diagram above. Each process has the same initial state and the same final volume. One process is adiabatic, one is isobaric, and one is isothermal. Which of the following correctly identifies the 3 processes? Well, adiabatic means the energy transferred is work and none is transferred as heat. So it's usually a rapid process that can happen very fast, and it has very little to no heat transfer. Isobaric is constant pressure, isothermal is constant temperature, and in a constant temperature isothermal process, the system usually evolves more slowly and stays in equilibrium with its environment. So B and D are the only answers with constant pressure. Because line 3 evolves faster than line 2, line 3 must be adiabatic. So therefore, that is answer D. Number 30, the driver of a police car hears an echo of the car's siren from a wall toward which the car is moving with a speed of 3.5 meters per second. If the speed of sound is 350 meters per second and the frequency of the siren is 600 hertz, the driver hears the echo at a frequency nearest to which of the following? So the Doppler effect, the frequency observed is going to equal C plus VR divided by C plus Vs, that quantity times the frequency emitted, where C is going to be our speed of sound, and VR is positive if moving towards the source, VR is the velocity of the receiver, and Vs is negative if moving in the direction of the source, Vs is the velocity of the signal. So our frequency observed is going to equal 353.5, and we added 350 plus 3.5 meters per second. That quantity divided by 346.5 meters per second, and right there we subtracted 350 minus 3.5 meters per second, and that whole quantity times 600 hertz, which was our initial frequency, and so that simplifies to 612 hertz, and that is answer E.